Thanks for attending. So my name's Peter Reynolds. I'm an analyst with ARC, and I'm going to talk to you about the Industrial Internet of Things, something that you're probably hearing quite a bit at the ARC conference. So what I'm going to do is I'm going to talk a little bit about our research and what this might mean. I'm going to really make it very basic in the beginning, and then it's going to get very tough and very complicated. I'm then going to invite a couple of great speakers who are doing some great things with technology, and then we're going to have a panel session that hopefully will be interactive, and you're going to ask lots of questions. So thanks for coming, and we're here for 90 minutes. So first of all, the Internet of Things, who coined this term? What does it really mean? Okay, so I had to go very basic. So as an analyst at ARC, when I study markets and I look at solutions and technologies and talk to people, well, the internet is a global system of interconnected computer networks using standard TCP/IP. Who didn't know that, right? Right from Wikipedia. So what does that mean? Right? And the things, well, so we're here at an industry conference and we're talking about things, but we don't normally talk about things. We talk about assets and we talk about plants and we talk about automation and software. So things, an object that one need not, cannot, or does not wish to give a specific name to, right? Or an inanimate material object as a distinct from a living sentient being. Great, right from Google, okay?
So one of the next big
this is what some people are saying about the Industrial Internet of Things. Please watch this video.
Things. See, now that we are extending intelligent sensors into everything, into the world of everyday objects, all of a sudden these objects are going to be endowed with agency. They're going to be endowed with the ability to give us feedback. The world is going to become intelligent and responsive and going to anticipate our needs. The world is going to feel like an extension of our mindedness. When everything becomes linked with everything else, as Eric Davis used to say, matter becomes mind. You walk into a room and the room knows how you like the lighting, and the song that you love starts automatically playing, and the curtains automatically raised, and the computer offers you your favorite snack. The full flourishing of these technologies promises to essentially blur the distinction between self and world. The entire world will have mind in it. It's how the cognitive philosophers David Chalmers and Andy Clark used to say, we've always been adept at dovetailing our minds to our tools, but when our tools start talking back, the loop will be finished. We will have fully spread our minds out into our universe. This is the Internet of Things. This is why it's a game changer, and this is why it absolutely rattles my imagination.
So I wish I had half of his energy, really, but I don't. So I thought about trying to duplicate that presentation, and I thought there's no way that I'm going to do it as an analyst. So that's Jason Silva. So this is Shots of Awe. It's a nice little video that's on YouTube, and it really, really made a difference when it came to, for me to try. You're not hearing me correctly? Got it. Okay, thank you. Okay. Yeah, so I have to stand very still. I'm used to a wireless mic, so you're just going to have to forgive me. This video I thought was very important to set the stage for automation and technology and software in the plants. So this is what people on the outside, with going about their daily lives, this is what they're hearing, this is what they're seeing with the industrial or with the Internet of Things. So, but what do we mean? We don't want to hear that video again. So what do we mean by the Internet for industry? So we think about this thing, and well, the fact is that we've got wired networks in plants, we've got field bus networks, we've got sensors, we've got network switches, we've got automation systems, we've got wireless HART, we've got LAN switches, we've got a lot of equipment out there that is our Internet today. Okay, so what are the things for industry? Well, it's the non-human stuff, okay? So this is the things like the field sensors, the final control elements, the rotating equipment, the production lines, the buildings. So these are all the things that are part of the things for industry, okay? So when ARC thinks about the industrial Internet of Things, we like to build models. Like we try to put things in buckets so they make sense. When we look at markets, we try and figure out, well, where are things going? So this is our model for the industrial Internet of Things. And basically it's tools to solve specific building problems for your industry. We do believe that fundamentally this is what it's going to do. It's going to solve problems. But there are some criteria that we think that's going to be part of all solutions, and we think that fundamentally, like the video we saw about the Internet of Things, when you walk into your house and you touch the screen and the music comes on, it already knows how you're feeling. We think that that's part of it. So we think that these tools and solutions are going to be easy for people to use. And the other thing is, because we think that there's going to be a lot of it, we think that this is going to be, the industrial Internet of Things is going to be at a price point where people can afford. Okay? So the main components that we see, excuse me, I'm just going to back up one slide. If you look at the outer rim, like these are the high-level criteria for the industrial Internet of Things. We think it's about connected machines, the connected enterprise, the connected supply chain, the connected workers. We think ultimately it's about bringing people, closer to the things that they care about. So on the inside, like Jason's video that we saw earlier, if we have the technology available when we get on our commuter train and our car starts speaking to us, we think that the technology and solutions in the plant are going to be just that. So the assets inside the process plant, maybe they will talk to us one day, right? If there's a business value associated with that, they certainly will. We think assets are going to be better able to predict health. Why not? If systems are more connected, and if the pump or the asset is connected to a software system, it is going to be able to predict its health. We think in terms of infrastructure and data communications. We think that cloud is a big part of this. We think that there's the storage is going to be immense. The cybersecurity requirements are going to be such that the information will be going to the cloud. We think that there's a new breed of software called analytics that's going to be part of this. So this is on the inner side, and we think that ultimately there's going to be a people, process, and system layer. So back to the cloud, we think that cloud is important because of cost. So like I said before, we think that the industrial Internet of Things has an important criteria of being at a price point that people can afford. We don't think people are going to build these systems in their plants and in their corporate offices. We think that they're going to start leveraging technology that's already available. And it's because of all these things. It's because of the iceberg. It's not the hardware and software costs that people see today. It's all the other costs, the facilities, the IT labor, to manage the systems, the maintenance, the security, the disaster recovery and backups. These things are all the hidden costs that most folks don't see. I wanted to share just a little bit of information. So other research that we're doing about cloud, and we see cloud as an enabler for the Internet of Things. The research I have here is from Juniper Networks did some research for the Cisco Global Cloud Index. So just a few data points here, and I'm just going to read them. So this commission study actually showed that global data center IP traffic is actually going to triple over the next 5 years to 2018. The IP traffic will grow at 23%. So these are consistent messages that we're actually seeing. So the information that's going to cloud service is not shrinking away. The study also revealed that 80% of the workloads will be processed by cloud data centers, 22%. So those numbers are actually changing. What else does it say here? So 59% of the workloads will be software as a service. So these are pretty good studies, and Cisco and Juniper, they're connected. They know where the data is, so we thought they were a pretty reliable source. 28% of the cloud workloads will be infrastructure as a service, so down 44%. 13% of the workloads are platform as a service. So what we're seeing is the expectation from the customers is more software as a service. So what does that mean to us? Customers are expecting more industry solutions. This is an example of a use case for IoT, and you may see some common themes when you go to the different ARC sessions. Down at the bottom, we've got typically a very disconnected oil field, or an oil platform somewhere in the North Sea. So what you might have is an umbilical cord with a fiber optic cable and lots of information. So we see where this is going to be most valuable is that a lot of this information is a stranded asset. It's not available to the people that actually need it. So we see more use of cloud services and analytical tools where we can better operate that facility at lower costs in a safer environment. So in a connected oil field example that we have here, we see that a lot of solutions will drive analytics programs, and these analytics tools will be used by people that are servicing the assets, and workflow will drive ultimately feedback to help reduce costs, dispatch workers, or dispatch equipment and parts to the rig. I had the benefit of sitting beside an Air Canada pilot on my way to Orlando a few days ago, and it was really interesting because what I learned was one of the most important connected assets is something that we all use, and that's airplanes. Well, there are actually a few exceptions, so I found out from the pilot. What the Air Canada pilot told me is that he says if you throttle the engines too quickly, there's monitors on the engines that transmits to a public satellite that's shared with multiple communications. It goes to the center in GE that's responsible for the performance guarantee on that engine. Feedback goes to traffic control and goes back to the pilot. So he said this is happening in minutes. Okay, maybe it's 5, maybe it's 10. So I think that the Federal Aviation Association was able to actually create this to make a safer travel for us. So there are cases out there outside of our industry. So the question is how are we going to do this for our industry? So I don't really want to present any more data about the Internet of Things because we've actually got some really good speakers here. So I'll say that we've got some really good foundational work going on. You're going to hear from Jim Wenzel from General Mills, who's going to talk to you about all the work he's doing, building applications and software as a service and leveraging cloud services. And then you're going to hear from Frank Berry from Air Products, and Frank's doing some great things by leveraging the IT technology and building common control rooms and tying automation infrastructure together. So without further ado, I'd like you to please join me in welcoming Jim Wenzel to come to the stage. Jim?